Hello and welcome again to FlippedHarber for Algebra 2. In this video we're going to talk about radical expressions and rational exponents. Our objectives for this video are to be able to write radical expressions using rational exponents, simplify radical expressions containing rational exponents, evaluate radical expressions containing rational exponents, and I want to end by showing you how to use these things with your calculator. Now our outline for this, we're going to talk about what a radical expression is and what a rational exponent is. We're going to take a look at properties of rational exponents. We're going to look at how to evaluate radical expressions with rational exponents, and then simplifying radical expressions with rational exponents. Now, a radical expression is basically a root. You should be very used to what a square root is. If I ask you what's the square root of 16, you should be able to tell me that that's equal to a plus or minus 4. Usually we just take the positive of that. The square root of 16 we usually just say is 4. Throwing a variable in there, the square root of x, shouldn't be that difficult. Throwing maybe a number and a variable, or maybe a couple variables, like the square root of 12xy. You understand what a square root means. We're looking for something multiplied by itself that equals 12xy. Now, there's nothing really inherently special about the square root. It's just one of many different possible radicals, many different roots. We can have cube roots. You've seen these. The cubed root of 8 is 2, but it just keeps on going up from there. We can have fourth roots, fifth roots, and sixth roots. And we can have numbers in there, we can have letters in there, we can have numbers and letters. We can even have something as complicated or even more complicated than the sixth root of 15x to the 5th. Now, what you need to realize, and here's the real magic of this, is that every radical or every root can be expressed as a fractional power. Now that's what we're talking about when we talk about a rational exponent. We see a fraction in the exponent, and what that fraction is telling you is that it is a radical, it is a root. So the square root, remember there is an understood 2 right here if we don't see any number, but the square root is equal to a 1/2 power. And the fact that it's 1 over 2, that same number as the radical, is not a coincidence. So if we have a cubed root, that's a 1/3 power. And here you can see that I distributed that 1/3 power because that's one of the properties of every power. If we want to square a product, we can distribute that square to each term in the product. Well, we can do the same thing with these rational exponents. If it's a cubed root, it's a 1/3 power. If it's a fourth root, well, no big surprise, hopefully, it's going to be a 1/4 power. Now, I wish I could kind of make these fractions look a little bit higher on these. I just think that they need to be pushed just up a little bit. Maybe I'll have to play with some notation or something in this software, but try to get those fractional powers just a little bit higher than you see them here on the screen. All right, so let's take a look, or let's remember some properties of all exponents. And really, I want you to remember that these are properties of all exponents, not just whole number exponents, because now we're introducing the idea of fractions in the exponents. These are true for everything, including these new fractional powers. If we take the product of powers, well, we can add the exponents. That's true whether they're whole numbers or fractions. If we take the quotient of powers, we can subtract those powers. And then when we have a power raised to a power, we multiply them. The power of a product, we've already talked about this actually, we can distribute that power in to each term. And the same thing when we actually have a fraction with an exponent on. That exponent can apply to the top and to the bottom separately. All right, now let's talk about evaluating radical expressions. What I'm talking about here is we've got a number with some wacky combination of powers and roots on them, or powers and fractional powers. So, the first thing, when we see a root and a power that match, what we do is we turn it into a big fraction where the power becomes the top of the fraction, and then the root becomes the bottom of this fractional power. And well, 3 over 3 is 1. So really basically this shows why a power and a root cancel each other out. Okay, in our next example we have a fourth root that is squared. Again, the power becomes the top of the fraction and the root becomes the bottom of the fraction. So we have 144 to the 2/4 power. That fraction, just like every other fraction, can reduce. So I reduce it to a 1/2 power. And what this 1/2 power means is that I'm taking the square root. So the square root of 144 is 12. Okay, so let's take a look at the third example now. Remember, when you don't see a number on the radical, it's an understood 2. Now, the square root of 48 cubed. Okay, not going to work out as great because the square root of 48 doesn't work out really great. So I can just leave it like this, or I can try to do something else, like maybe take a 4 out of there or a 16 out of there, and that 16 is still cubed and whatever still has this power. Alright, now let's take a look at simplifying radical expressions when there's some letters involved. So now we've got some variables here. So let's take a look at the first one. Remember that this cubed root right here goes to both the 56 and to the x to the 9th. So I can actually take a cubed root of part of that 56. The cubed root of 8 works out well. It's 2, so that comes out of the cubed root. The 7 stays behind, and look what has happened to the power on the exponent. I've taken the 9 and made it the top of the fraction. The radical, the 3, becomes the bottom of the fraction, and that simplifies very, very nicely to x cubed. Okay, well, let's apply our power rules here where we have a product. So we have the 5th root of x to the 7th times the 5th root of x to the 6th. And we can go ahead, change those to fractional powers. Again, the power always becomes the top of the fraction. Now, our rule with exponents is when we are multiplying, when we're going x to the 7/5 times x to the 6/5, we add these powers. And this actually isn't that big of a deal. Adding 7/5 plus 6/5, we have a common denominator there in the exponent. So x to the 13/5. That means that it's a power of 13, a root of 5. Moving on to our next one, we have a cubed root. Cubed roots of negatives, not a big deal at all. When you take the cubed root of a negative number, you get out a negative number. Square roots, fourth roots, sixth roots, those even roots of negative numbers, those kind of cause a problem. But cubed roots, fifth roots, seventh roots, the odd roots of negative numbers, no big deal at all. The cubed root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. The cubed root does not work out real great with the 2, so we just leave it. The cubed root of 2. And that fractional power, this 3 as a denominator on the 9 and on the 3 works out great. X to the 9/3 is x cubed. y to the 3/3 is just y. All right, let's take a look at one more. We've got 12 to the 1/4 power divided by 12 to the 3/4 power. Our property of all exponents, not just fractional exponents. We subtract those powers, and we actually end up with a negative power. Now don't forget, this negative in the power means that you flip it. It actually goes to the bottom of the fraction. So I'm taking the square root of 12 on the bottom of the fraction. The 4 comes out of the square root as a 2, the 3 gets left behind, and we have 1 over 2 times the square root of 3. Now if this were pre-calc, I'd let you leave it like that, but since this is algebra 2, we are going to multiply by a square root of 3 over a square root of 3, and this is going to rationalize the denominator. What I end up with is the square root of 3 on top. The square root of 3 times the square root of 3 on the bottom just turns into a 3. Multiplied by the 2, we have a 6. That process is called rationalizing the denominator. All right, now let's talk about doing these fractional powers or doing these roots in your calculator. If I want to take a cubed root in my calculator, my absolute favorite way to do it is to make it a 1/3 power. On my big fancy schmancy calculator, I do have a cubed root button, and I even have a generic root button where I can do a 4th root, a 5th root, a 6th root, and so on and so forth. But my favorite way, the fastest way for me to do it, the fewest number of keystrokes, is making it a fractional power. So I go 81, and then my little caret, which means to the power of 1/3. And that's a great way to find the cubed root of a number in my calculator. If I want to do a 4th root, well, I could do the same thing. I could go caret and then 1 over 4. Or if I want to, totally legal, makes total sense to my calculator, to go caret and then instead of 1 over 4, just go 0.25, because I know that a quarter as a decimal is 0.25. So this is one of those things that you want to get comfortable with before the test day. Try these out with your calculator. Make sure you know how to use yours, whether it's a more basic one, whether it's one of the fancy schmancy ones. Know how to use your calculator. Okay, that's it for this lesson. It's time for you to try some of these on your own. I'll see you in class, and I'll see you online.